everyone. This is kind of the companion, I guess, to the last lecture of intelligence. This is Unit 5, Lecture 7, Intelligence Testing. And it's exactly what it sounds like. It's how do we test? How do we measure intelligence? Because remember, psychology is a science. And so if we're going to draw conclusions, we want data to back it up. And how do we measure something that's so just conceptual, like just this idea of intelligence, which is really defined differently by a lot of different cultures in a lot of different ways. So how do we make it a little bit more concrete? Well, we do it with tests, and that's what today's all about. And just like the last lecture, the people are going to be pretty important, and we're going to associate, just like we associated in the last lecture, people with certain theories about intelligence. Today we are associating certain people with their tests that they designed to measure intelligence. Definition sounds basic. Method for assessing and comparing mental aptitudes using numerical scores. But the important part here is the comparing part, because a big part of how we understand intelligence is by comparing, right, wrong, or indifferent, is by comparing one person to another. Is one person more intelligent or less intelligent? And if they are, what does that mean? And so the comparison part is really kind of the point. Okay, we are going to start off. I've got kind of two big categories within this topic. And the first one is in history of intelligence testing, like who designed it, where did it come from, what does it look like today? We're going to start with Alfred Binet. He developed the first standardized intelligence test. He was French, and he was commissioned by the French government to design a test to identify children who would have problems in regular classes. Now, his intention wasn't to label children, and we kind of get a little bit concerned about that today. Like, oh, do we put a label on a kid and then they just think they're a certain thing for the rest of their lives in terms of their learning? And that's not what that wasn't really a concept back then, at least not in the way that we think of it today. But the idea was to be able to measure students, to be able to teach them better and serve them better. So I guess I'd like to think that it was well-intentioned. And so what did Binet do? Well, he created a test to find a child's mental age. And a child's mental age is the level of level of performance associated with a chronological age. And I'm actually not even loving that, but I already made the slides and your notes, so I'm not going to change it. But listen carefully. So if you want to reword it, you can. Basically, your mental age is your age based on your skill level, not how many years you've been alive. So I might be alive for 38 years, but if I can only perform the skills of an average 20-something, then that's my mental age. Obviously, this is easier in children. So if you have a 7-year-old who is just now starting to write a full sentence, their mental age would be like a 5-year-old. And so what Binet was saying is that all kids had similar development. So they developed in a similar type of order, but at different speeds. And so a dull child would score much like a typical younger child, and a bright child would score like a typical older child. And now on to Louis Terman, who took Binet's test and brought it to the United States. And Terman was a psychologist at Stanford, and he took Binet's test and kind of revised it specifically for U.S. children to be used widely across the United States. And his version is named the Stanford-Binet IQ test, which is still used today. As I said, he was a psychologist at Stanford, and hence the name change. And he believed that his test that he designed or redesigned revealed someone's innate intelligence. And in case you don't remember, the word innate means born with. So whatever level of intelligence you have when you're 5, if you're average, then you're likely to still be that average level of intelligence amongst your 10-year-olds, and then your 20-year-olds and your 50-year-olds and so on. And so you have this sort of set of intelligence already in you, and it's kind of stable, and we'll get into that in a little bit, but it's a fairly stable number, and then this test was meant to help psychologists determine what that number would be. In today's Stanford-Binet test, it is given orally, and the style varies according to the test taker, whether you're a child or an adult. If you're a child, you are asked to copy some figures or solve everyday problems. If you are an adult, you are asked to solve analogies, explain proverbs, try to find a similarity amongst some what seems like random sets of words. And what this test allows examiners to do is to find that mental age we talked about. And this is the age where you can answer all the questions. So you'll get, say, 5 questions. If you get them all right, the next batch of 5 is harder. You get those all right, the next batch is harder. And this keeps going until you cannot answer any more questions because they have gotten too hard. And then that is where your mental age comes from. From there, you can develop an IQ. That's probably a familiar term to you, and that means an intelligence quotient. What's this number that we can attach to your intelligence? This IQ formula was designed by a man named William Stern, and what they found is that it works well for children but not adults, and I'll go through a demo in class as to why, but basically the math just doesn't kind of work out as well. It's no longer computed that way, but we've kind of kept that language. And we still use an IQ test to describe kind of all of these different types of tests. David Wechsler is another test, or is the creator of another test that is still actively used today. In fact, it's the most widely used of IQ tests. And he developed the Wechsler Adult Intelligence Scale, and there are also versions for children and preschoolers. And his test, the WAIS, is something that hopefully you'll get to experience. I'm pretty sure I either have given you or will give you a testing experience day where you'll get to try this out. And it measures both your overall intelligence and provides individual scores for certain types of skills. The ones here: verbal comprehension, perceptual organization, working memory, processing speed. What psychologists have found is that both the overall intelligence scores and the scores for these other things do tend to be, on your average person, relatively close. However, you can be more precise with the breakdown of each score, and if you notice huge differences, for better or worse, they can point out cognitive strengths or weaknesses. For example, if you have a very low verbal comprehension score, but then score well in the other ones, that could suggest a reading or language disability. So maybe you are able to do those other things just fine, but if your verbal comprehension is low, maybe it just indicates, okay, this person needs support in this area, but all their other levels of intelligences are average and on par, nothing to be concerned about. Okay, so overall types of tests. That's the history of tests, and that's how we got to tests. So things like the Stanford-Binet and Wechsler's WAIS test are still used today, but there's also a whole bunch of other tests that we use to measure intelligence. And one in particular that you either have taken this year or that you've taken within the past year, most likely, and that is the ACT and SAT. Which one is it? Oh, shoot, I have it on the screen there. You're going to... You know. Okay, first of all, let's talk achievement tests. Achievement tests are more like your regular old-fashioned school tests. So these are intended to reflect what you already learned, your current level of knowledge, perhaps like a test you would take for me in this course, or even a test like the Explorer test or the STAR test that you had to take when you're younger. I don't think you take them as seniors anymore, but those standardized tests. What can you do? What skills can you have you mastered that you can demonstrate by taking a test? An aptitude test is intended to predict your ability to learn a new skill in the future. Like, how well could you do, like in college or on a job? And so, yes, the ACT and SAT are these types of tests. Theoretically, they should demonstrate your critical thinking skills, your general ability to learn. And so what that would tell a college is, yes, this person is likely to be successful here based on their score. So it's not simply what did they learn in high school and how do we measure that? It's what would they be able to do if we accept them as a student? We'll discuss in class, but which one, I want you to think about this, which one is more connected to intelligence? which style of test do you feel like accurately would represent someone's intelligence? I'll give you a hint. It's not exactly a right answer to this question. Oh, look, I did have an example there. I don't know about my intelligence when I'm filming this. For a psychological test to be acceptable, it must fulfill 3 criteria. And these are the hard parts of this lecture. They're tricky because they feel similar. I feel like when I learn them, I tend to blur them together, and I definitely have to stop and think. So as needed, you can stop and think as we go through these. They include standardization, reliability, and validity, and I'm going to go through each one. The first criteria of a good intelligence test is standardization, and we find it by standardizing the scores. I know you can't use a word to define the word, but what happens is that all of the items, all of the questions, tasks, whatever that are on a test are normed by testing on a random representative sample population first. And you're like, what, huh? Let me give you an example, and that will kind of help me explain the rest of this. For our own AP Psych test, College Board will write the test like a year or two, or the questions a year or two in advance, and give them to college students who are taking a similar psych course. And then based on their scores, they will fall into a normal curve. I'll talk about that in a minute. And then that's how College Board will determine what score warrants a 3, a 4, a 5, and lower, of course, as well. In other words, average scores are calculated from a sample group. So those sample of college kids. And the reason it's a representative sample, it has nothing to do with the fact that they're in college and you're in high school and like, that's unfair. How can we be compared to them? It's based on what you're learning. This AP Psych course is supposed to be comparable to what your average college student in a basic Psych 101 course would be learning. So by allowing them to take the same test that you're going to take, it tells the colleges like, look, these high schoolers' scores are the same or would have a ranking similar to what your college students would produce. If that's fuzzy, we will talk about that again in class. But the future scores, you guys will be compared to the norms of those college kids. And then that indicates, like I was saying, to the colleges that yes, students from AP Psych in high school are comparable to those if they had completed that college course. Therefore, we'll give them college credit for it. Those scores, just like most IQ tests, do fall into a normal curve. And then at this point, like in current day, the results are based on a deviation or percentile ranking instead of a simple IQ score based on that formula we saw earlier. So if you take an IQ test in this day and age, on average, most people score around 100. If you get higher, I'll get into these specifically in a little bit, but if you go higher, you're considered gifted. If you go lower, you may be considered as having an intellectual disability. Again, I'll get into those actually in the next lecture, so I don't want to get too much into it right now. The scales are re-standardized periodically, meaning let's say College Board develops an AP Psych test that they want to use over and over again over the years. They will actually give that same test to college students again to make sure that the scores are still accurate to what your average psychology student should be learning. So it's not like they do it once in the 1950s and now we're just using the same test averages forever and ever. And that brings us to a connection to the Flynn effect that we'll talk about in class, but I do want you to ask yourself, like, what could happen based on what you know about the Flynn effect if someone took a test now and that same test is taken 10 years from now? Do the scores mean the same thing? We'll get to that, like I said, in class. Sir Francis Galton is the one who kind of gets the credit for that idea. And not just that idea, because there's actually, there's merit to it. But he believed that intelligence is quantifiable. So in other words, we can put a number on intelligence. We can measure intelligence. And that is normally distributed, that most people fall in the middle. And then we have people that fall on either extremes of this intelligence scale. He invented percentile ranks and the concept of correlation to be able to determine people who fell above and below this intelligence average. And while this is a general concept that we still use today and has proven to be pretty reliable, he kind of took it to a different direction. He he also coined nature versus nurture. He's the one who kind of invented that idea and linked it specifically to intelligence as he tried to investigate, is intelligence hereditary? Is it something you're just born with and so there's not a whole lot you can do to change it? Or is it a product of your environment based on your schooling and how you're raised and the people you're around and whatnot? The thing that he did that was a little bit sketchy is he was all about eugenics. And if you know anything about eugenics, essentially what it is trying to find the best qualities of people and then have them make babies. So if you found a really smart person and another really smart person, they should really be the ones making babies because then they'll make really smart babies and so on and so on. So everyone's just going to get smarter and smarter and smarter. But this is also linked to things like racism and eye color and body type, and saying only like the perfect type of person should really be having babies to carry on their genes. So we don't like that idea, but we are pretty much still using the ideas that intelligence is normally distributed, and we psychologists are still fascinated by the idea of nature versus nurture. The next criteria for how to make a good psychology test, or an intelligence test rather, psychology tests really in general, but we're talking intelligence, but any psychology test, is that it needs to have reliability. In other words, the test produces consistent results over and over again. So it's not like if I gave a test and 1 year and teaching the same way, maybe with all these videos, and 1 year everyone averages a 70% on all the tests, and another year everyone's averaging a 30%. Is this test reliable where no matter who takes it, the scores average out like is expected? This is determined in 3 ways. Either by having a split half reliability. In other words, scores on 2 halves of the test are compared. So having a bunch of students do only the evens, having a bunch of random representative sample students complete only the odds, and on average, are the scores similar? Because if they are, then the test is probably reliable. Perhaps coming up with 2 alternate forms. So having random representative samples take 2 different tests, but where the questions are relatively similar in difficulty, again, do the scores produce average results and form that normal curve? And then finally, the test and retest reliability, using the same test on 2 occasions to measure consistency. So if I give you guys a test on, again, an IQ test, so maybe not on psych, and I give you an IQ test in August, and then I give you the same one in June, do your your scores stay consistent? A flaw with test and retest is if you're trying to see that someone can consistently get the same scores, what if they remember the questions and they just did better because they remembered the questions? So that's a little bit tricky. One last example, I have a note to myself that I think will help is we know like a tape measure is reliable, okay? Because no matter how many times you use it, test, retest, we know that it's going to produce that same consistent score. So a tape measure is a good example of a reliable test. Can you tell I'm not super confident in my skills on this one? But we're getting there. We're getting there. The more we use these terms, the better we'll get at them. The last one is validity. And I feel like this one I really get quite well. So hopefully you will by me teaching it really well. Is asking whether or not a test measure or predicts what it claims to. Is it accurate and useful? The first type of validity is content validity, where the test actually measures the intended behavior or trait. So for example, a road test on for a driver's license is considered valid because you are being tested on how to drive a car. If I had you take a math test for to get your driver's license, that's not valid. It's not testing the intended behavior. Like, what does a math test have to do with whether or not you can drive a car? Another type is predictive validity, where a test predicts an intended behavior or trait. And this might be like the idea of like an SAT or an ACT. By taking an ACT or SAT, and if you score really high and it tells a college like, yeah, they're going to do well in college, you go to college and you actually do terrible, maybe that ACT or SAT was not actually a valid predictor of your academic success. It's important to know that tests can be reliable but not valid. In other words, if I gave every 16-year-old, a math test for a driver's license, yeah, it might be reliable and everyone's getting average scores because you've all taken at least Algebra 1, but it's not valid because it still doesn't test the intended purpose, which is whether or not you can drive a car. I have some more examples on the next slide. And I'm just realizing I'm looking at my timer here and I feel like this is long enough. Let's save these examples for class because this is a tricky concept. Standardization, reliability, and validity are all actually pretty tricky and I think would be better explained when we actually practice this in class and do some examples in class. So as long as you got the notes down, you are good for now.